really long title, and my teammate actually said I should have changed this title to Infrastructure Lifestyle Management and Security Lifestyle Management, because we're going to be talking about people and process and not so much about technology. I'm someone who's really used to doing live demos on stage, right? Most of the time, I really prefer to be coding. I prefer to be showing something live and showing people what to do, right? But the reality is that I've been teaching a lot of patterns and practices for a long time. In 2018, I was sitting in a learning circle with a bunch of folks who were looking to get into the cloud space and security space. And they were like, what are the terms that I need to know? What are the job descriptors? And I came back to this diagram, which I don't even have the originals of anymore, so I had to have someone recreate it for me off of this blurry picture. And I realized that not much of this has changed in 6 years. So it goes to show that infrastructure and security lifecycle management is not new, right? Platform is not new. We've had it for a very long time. In fact, we've had it for years. But we never fully defined it. We never fully decided what it was for ourselves. So infrastructure security lifecycle management is the practice of changing infrastructure or security resources. And you think, such a simple definition. But is it? It turns out change is kind of complicated, but you can generally divide it into 4 types: create, read, update, delete. It looks like a Terraform provider, right? Has anybody written one? It looks a lot like this. And the reality is that when we think about change, we think about these kinds of behaviors in our environment. These are simple patterns and simple practices, right? These are things that apply to infrastructure as code. These are things that apply to even dynamic credentials. But why is it so hard? Well, it's kind of hard because of the way we think about these resources. We think about them across data center, public cloud 1, public cloud 2. Some people are even dangerous enough to venture into public cloud 3, right? And so when we think about life cycle management, we think about it across all of them at once, right? We think about it as one rule, one practice, one uniform way in which we change resources. But it doesn't actually look like this. It looks a little more like isolated cells, right? We hear a lot about cell-based, but I use the cells not as cell-based, but just as a way to show you that lifecycle management is going to be different even within your data center, different between public cloud 1 and public cloud 2, right? And the way you're going to divide and think about create, read, update, delete, such simple changes are going to be different across even subgroups within your data center, public cloud. So what are we talking about today? Well, I said, we're talking about lifestyle management for infrastructure and security, but we're actually going to be focusing more on foundations. What are the building blocks that you need in order to do infrastructure and security lifecycle management at scale? And more importantly, how does this affect people and process? Because as you go further up to the top, right, to systems of record, that changes the way your people need to be thinking about infrastructure and your people think about security. And that is the hardest thing to change of all. That's not something you can do by create, read, update, delete. So let's talk about that a bit. We're going to start with the bottom. We go bottom up. I didn't go top down, notice, because we're starting about the foundations, right? So the first set of foundations you need to think about for infrastructure and security lifecycle management are about monitoring and observability. This is read at its very core. If you don't have information, you can't take action on any system, right? So let's talk about vulnerability patch management. You heard about the jokes this morning about developers not liking to patch, right? But when you think about what is the foundation of vulnerability patch management, well, you think about reading information about whether or not the patch failed, whether or not there are other machines out there that still need updates. You need information, right? How many people in here have had security teams or are on a security team and you've asked, how many machines need to be patched, right? It's a very common question, but with a difficult answer. So this is just the example, but more broadly, when we think about monitoring and observability as a foundation, we think about audit, right? This means changes to infrastructure. It means systems access. We identify drift, we identify vulnerabilities. We validate policy conformance, right? And validate artifact provenance. These are really important foundations to start with, right? Because if you don't have these foundations, you can't make changes at scale. So if you don't have this basis, it's kind of hard to build everything else. What does it mean for people and process? Well, when you have information, you can encourage self-service, right? We talked a lot about developers having self-service, security teams having self-service, platform teams be able to empower to build modules and get the information they need about the infrastructure and security resources, right? So from a people standpoint, having monitoring and observability encourages people to get information they need to build confidence for a change. If you have information, you have more information on how to build a change properly. From a process standpoint, we think about auditing and documenting how we evolve our system. This is beyond the architecture review documents. This is beyond how we think about change management. This is really basically documenting system evolution in a systematic way. And we're iterating on a platform interface, right? We're not looking at abstractions. We're looking at interfaces for someone to get information. All right, so what's the next foundation? That's create. They're a little out of order. I wanted to make it CRUD, but it turns out it doesn't work that way. So the next foundation you have is modularization and access control. They kind of go hand in hand, right? Because when we think about least privilege access control, it implies that you've modularized how people access your system. So let's take an example again. Patch management. What gets disrupted when we patch? What's the blast radius, right? If we make those changes and we make the patch, what's the potential application dependency that we might impact? What are other systems that we might affect, right? Modularization answers that question. And from an access control standpoint, you're thinking about how do you give people access to machines for patching. Some of this is automated, but you might not find it automated at all. Sometimes you're doing it manually, right? You're going into the machine, you're SSHing into it, and you're trying to fix it, right? That's the idea of create, which seems kind of strange, right? Modularization, access control. But if you don't group, right, it's very hard to create resources in the first place. More generally, right, this is about isolating changes to parts of the system. This is what we talk about when we think about security least privilege access. This is what we talk about when we say build Terraform modules, right? You're forcing people to think about how to group resources in a way that they can make atomic changes local to that specific group and not to anything else. And we're thinking about decoupling infrastructure dependencies and from a security standpoint, decoupling identity from access policy. Because identities change, access policy and how it's tied to that identity also changes. Decoupling the two means you can evolve and scale who has access, what has access, and how much they have access to, right? Authentication, authorization at scale. So when you think about these two, they go hand in hand. They go hand in hand in creating access to parts of the system, creating the system itself. So from a people and process standpoint, there's a great analogy about kebab and cake teams, right? So it's kind of funny, but you could think about kebab teams of sort of the silos, right? You have a security team that says something needs to get patched. We'll hand over to a platform team to say, hey, you have to implement the patch, and then the developer team who says, hey, you broke my application because you patched. Right? So those are kebabs versus a cake, right? Where you have some platform team working with some infrastructure team together and they identify what needs to get patched. And then maybe somehow that gets handed over to an application team, right? So kebab and cake teams are a way of thinking about information handover, but as you create your resources, right? Conway's Law, it's going to match exactly how your teams are organized. So you have to think about carefully what it means to create resources and how you group them and how they match the teams managing them. And more importantly, as a team, agree on interfaces over implementations. I had a really interesting discussion with a developer who said, I don't like platform abstractions because it hides away things. I want you to agree with me on a platform interface, which is fair. So think about interfaces over implementation. Process changes pretty significantly when you think about modularization and access control. Because now you're trying to balance productivity and security. If you have the ability to isolate changes to one subsection of the system, right, you have the ability to make another team productive because they can extend on that system. And it supports that flexibility. All right, so the next one up. We're going up. There we go. Standardization and remediation is all about update. You're like, what does standardization mean? Why are you talking about standardization here? Well, it turns out you inevitably have to standardize, especially if you do want to scale, right, at the top level. So again, going back to my exciting patch management example here, what do we need to do to fix the vulnerability, right? That's standardization. Can you do the same automation once across thousands of machines and fix the problem? The answer, maybe. We don't know. From a security standpoint, you're thinking about remediation. This could be any vulnerability, but in the case of patch management, you're thinking about how do I roll out the patch? What are the ways for me to ensure that this vulnerability is solved, right? And do I have a compensating control in place in case I can't solve it or I can't resolve it? So from a more general perspective, beyond patch management, standardization is about developing consistent deployments. It's about improving the predictability of changes and rollbacks. If you don't standardize your infrastructure, you cannot make large-scale changes to resources with confidence, right? Edge cases means weird behaviors that you can't predict. That's why you can roll a bunch of changes with the Terraform apply, and the minute you start making some imperative calls somewhere else, it might just break what you've done, right? So there's something to be considered, especially with standardization. From a security standpoint, we love standardization. Standardization means we can audit more and remediate less, with less effort at least. But in order for you to remediate properly, you need to develop a baseline for detecting anomalous behavior. What is normal? What's not normal? If you don't have a standard, you don't know what's normal in your system. And more importantly, you can't remediate quickly. And just to prove this point, right? There was a time in which I was remediating without any standardization. There were some bespoke VMs in a data center, and I had to do them 2 or 3 at a time. This took 4 weeks, which seems not a long time for a data center. But that's the problem. They were all created at different periods of time, and there was no standardization in how anything was rolled out. There was no standardization on versioning. There was nothing of the sort. So I had to take 4 weeks to do it. Versus in a public cloud where we had implemented some standardization, we had forced some templates in place for people to create things, and I was able to do a broad swath of machines in less than a day. So remediation with standardization is really powerful. It expands the footprint of what you can fix. But from a people and process standpoint, this is the one that most of the time it's the hardest thing to justify. It's really hard to justify to another team and say, I will force you to standardize on a module. I'll force you to standardize on a Waypoint template. I'll force you to standardize on a set of AMIs that I've built by Packer, right? It's really hard to roll this kind of thing. Oh, what my favorite is, I will force you to use secrets from Vault, right? The refactoring effort is really hard to justify. It's a long-term investment with a short-term gain, and we oftentimes don't want to make that effort. But the point is that the short-term gain that you get from it is actually, the long-term gain you get from it is really important, because that means that you can focus on value over the technical details for a long period of time. You want to think about establishing evergreen standards, right? It doesn't mean you have to argue over every interface and you have to argue over every standard and how exactly you want to be naming your modules and how you want to be naming your boundary scopes and things like that. That's not necessarily the point, although you can argue for that for days. But the reality is that you want to be thinking about how those standards are going to affect your organization long term and how you are able to set an interface for someone to evolve on. From a process standpoint, this is even a little harder at times because you have to figure out how you're going to develop consistency in process. If you might have a dev team that uses one CI framework and another dev team that uses GitOps, and then another dev team that doesn't even use CI at all. Right? So process is a little bit different for everybody. And the way they make changes means that, well, there's no standardization. And it's very hard to remediate if any one of those systems tends to be a little bit off. So you want to develop some kind of consistency in process and hopefully standardize them in one place so you can control how you're deploying to production, for example. And finally, this allows you to document some edge cases, right? There's never going to be a way in which you're going to cover every developer use case or every platform team use case or every data scientist use case. So you do have to document some of these edge cases, and that is where you're going to break process. But you do have to make note of them. So we're building our way up. We're finally kind of at the end of the 2 pillars between infrastructure and security, and that's immutability and ephemerality. I call this delete. This is the hardest idea for any team to understand and grasp. If you tell someone that we're going to delete your machines instead of updating the packages on them, they will cry. Most people get really upset, right? It's not intuitive. You're telling someone, I will delete that machine, potentially incur downtime, in favor of creating something new, right? And that is not exactly the easiest mental shift to have. So from an infrastructure standpoint, we're going toward replacing the machine in vulnerability patch management instead of updating them in place. And ephemerality is sort of the other side, right, of the security coin. That's, can we get short-lived resources? You've heard about dynamic credentials. You heard about how we get short ephemeral just-in-time access, right, for developers and platform engineers through Boundary. But short-lived resources are now a new form of compensating control. If you mitigate how long it takes for someone to how long someone has access to a machine, you could potentially mitigate how long that life cycle is for someone to compromise it. So immutability and ephemerality are sort of two sides of the same coin because you can use immutability to help with ephemerality, right? So immutability, for those, oh, if we could go back one, sorry, I went back too fast. There we go. Immutability is changing resource by creation and deletion, right? And that means you get to support lower risk refactoring patterns. These are your large scale blue-greens. These are your really large scale abilities to just change platforms just because you built your old platform, you're building a new platform, you're going to migrate, and then you're going to sunset the old platform kind of thing, right? But ephemerality is a lot more nuanced from a security standpoint, right? That means your short-lived credentials reduces the attack surface, and it means it also supports resiliency patterns, because once you get used to resources changing and deleting all the time, you pretty much support any other pattern that you have at scale, right? So that's why immutability and ephemerality, if you're going to take away one thing from this talk, the two that go hand in hand are sort of the top of these two pillars from a lifecycle management standpoint. From a people and process standpoint, as I mentioned, this is the hardest thing for people to understand because you're shifting the paradigm from static to dynamic. I work a lot with developers who are trying to use dynamic database credentials from Vault. And the first thing they ask me is, how do I get new credentials? My application never needed to reload before. I never needed, I just restarted, or I expected my ops team to restart it. And so there's an enablement portion to this where we have to show, here's how you do retries, here's how you understand behaviors, here's how you make your application more resilient. And you think about immutability to larger use cases, right? Forget about secrets, but think about even large-scale deployments, right, that you might do in Terraform. You can do full blue-green deployments on a lot of different stacks, different networks, different clusters, right? If something is wrong in one cluster, you delete that cluster and you just move it somewhere else. I've done that many times. And just as a perspective, right, it's pretty scary the first time. The second time you do it, it gets a little bit easier. It's about practice. And so from a people standpoint, it's about practice, the practice of immutability. From a process standpoint, you're developing a constant rate of change. Rate of change is something that you measure in your organization, but you don't really necessarily care that much about it until you realize that nothing has changed. There's someone who proudly told me, like, we never turned off a network switch for 10 years, which isn't a good thing. Entropy happens in the system. So the reality is with process, as you move to immutability, ephemerality, you're forcing yourself to have a constant rate of change. And you're using provisioning as a form of remediation. You're no longer saying, I'm just going to update this in place and patch this, and uptime is my measure. What you're doing is you're saying, I'm provisioning and using the short life cycle, the short metric, as what I'm measuring by today, and that's how I'm going to patch. Okay, so we've gotten past the pillars. Let's go to the roof. I call it the roof because I had no other term for it, but we'll call it the roof. You'll notice as code was not an infrastructure lifecycle management because in my perspective, they're not really building blocks, right? It's a building block for scale, but it's not a building block for lifecycle management necessarily, right? But it will facilitate scale. So let's talk about that for a bit. As code, right? We're going back to vulnerability patch management again because it's our concrete example. So we're going to think about how often we can push a commit to update this image, right? Recently, if you haven't checked out the escape room here at HashiCorp, one of my images got a little messed up. So I ended up pushing a commit, pushing it to production, and it got automatically rolled out, right, to all of the escape room assets, right? So the point is, like, you can do this on a regular basis. You can push a commit to update the image and replace whatever infrastructure you do have very dynamically. And that's the power that you have as code. You don't have to go in looking for the resources and manually updating. You can just make one push, and everything gets updated. From a self-service standpoint, this means, can a developer patch their VM without asking any operations team? They just click and say, can I just patch this? Or if a notification just shows up and says update, they don't even care it's a patch. They just update, right? And so self-service is really powerful because it means not just self-service for developers, it means self-service for cloud platforms, self-service for customer support, self-service for anybody who needs some kind of interface to infrastructure, and they just don't care about the details, right? Instead, you've handled the predictable changes of behaviors, you set those standards in place so they're predictable. And the top, which is a system of record, right? When you talk about patching, you're asking about what exceptions exist. What couldn't we patch? Does it have a compensating control? You have to make note of those things, right? Because the next time you review your footprint, you have to figure out what you have to patch, right? You have to know what you made an exception for. So from a general perspective, right, as code is building policy or configuration for automation, right? This could be policy to check your vault policies, it could be policy for infrastructure as code even, right? And the thought is that as code allows you to have orchestration across systems. That's why if you had Terraform and you've built it for years, that allows you to use something like stacks to enable orchestration across many, many, many forms of state. Right? As code empowers orchestration, larger scale orchestration. And when we think about self-service, this is where we think about abstraction. You're building an abstraction for complexity of knowledge. You always need an interface. You don't always need an abstraction. But in the case of self-service, you will build the abstraction for complexity of knowledge, especially if you're trying to scale. And this means that anybody can extend that system to support their business needs. They don't have to ask someone else. They don't have to ask the poor platform team who has 200 PRs open to try to merge something back into Terraform, right? They have the ability to be confident that their change works because you've standardized on that system, and you've ensured that you've done your due diligence and testing. And finally, the system of record. This is the top. This is the hardest thing to achieve. How do you build an inventory of infrastructure, secrets, identities, policies, and I missed one, services? This is the service catalog dream, right? And enabling visibility and orchestration across all of these components in the stack is sort of the dream that you want to achieve at scale. This is why we think about service catalogs. We think about inventory. We think about basically consolidating systems of record. But what's important to recognize is that we often think bottom up. We shove all of our infrastructure resources and the asset information we have into a CMDB, and then when we go back and we're like, what application metadata matches? We go bottom up, right? We don't think about going top down, which is let's work from the business level, the application level, and then identify how that goes and tags into infrastructure assets that relate to our business units, right? It's very hard to do top down. We tend to do bottom up, but then there's a gap between application systems of record and infrastructure systems of record. So we have to kind of meet in the middle with the two. So finally, from a people and process standpoint, this is another paradigm shift. Again, every time I talk about as code, everybody's like, I don't want to click, but I kind of miss the clicking. I want to be able to provision resources by clicking something and then, provision. But you're shifting a paradigm not from clicking resources but to selecting systems. You're giving the people abilities to choose systems. You're not having them click on specific resources, right? So when you choose systems, that means you capture all of those pillars that I mentioned before and everything, all of the building blocks in the pillars. And the important thing to recognize is not everybody likes this model. So you do have to offer some kind of escape hatch for any edge cases. These are the next generation. This is someone who says, I like Terraform. I'm a developer, and I want you to give me Terraform to manage. From a process standpoint, you're able to accommodate a rapid rate of change. That's the key for when you scale. You have to accommodate the constant change that's happening in your system. And you're able to use systems of record to assess the blast radius of how a change affects your system. Right? A system of record means visibility. It goes and cycles back into monitoring and observability. Right? But if you can achieve that top-level system of record, it means you have the ability to assess your blast radius. All right, so let's wrap up for a second. I'm going to flash this diagram up on the screen again so we can remind ourselves of the building blocks in the pillars and the building blocks at the top for scale. Right? But at the end of it all, really what you want to be thinking about are the different parts of your system. I'm not saying this is my data center, this is my public cloud, this is my public cloud too. I'm saying these are my applications in this subgroup, my VMs in this subgroup, my Gen AI workloads in this subgroup, in each of these spaces, right? And go through the exercise of discovering how far up you are in those building blocks. Maybe you only have monitoring and observability, the basis, right? in parts of your systems. Maybe you manage to do everything as code in some other parts of your systems. Maybe you're even further along, and other parts of your systems have established systems of record, and they look amazing, and you have visibility into that system, right? And you want to achieve the system of record, so you're going to think about all the weaker parts, or the parts of your system that just aren't quite there, and you'll refactor and replatform to get them to a better place. So what does it mean when I talk about security, lifecycle management, and infrastructure lifecycle management at scale? It means designing and building for change, which affects people and process. That means it really is infrastructure lifestyle management and security lifestyle management, right? So it's complicated, but if you do want to learn more, check out some of the other sessions that tie some of the technical implementation to ILM, SLM building blocks. You'll see some of the recordings from HashiCorp 2024. And if you want some specific examples and want to assess this framework for yourself, you can try some of our tutorials on developer.hashicorp.com. Thank you.